Good afternoon, students. We will start with the today's lecture. In the previous lecture, we have seen we have started with the chapter magnetic forces, right? And boundary conditions we are not studying already, I told, right? So in that we have covered the force on a moving charge, right? And we have solved few numericals based on that. Then force on a differential current element and the numericals on it that we have seen in the previous class. Next, in today's class, we will continue with the numerical based on the force on a differential current element. The next topic is force between differential current elements, right? I'll tell you as and when it comes there next in the next topic, and we'll solve few numericals, right? Okay, we'll consider this numerical. The field magnetic flux density B is given, right? Millitesla is present in free space. Find the vector force exerted on a straight wire carrying 12 amps in the AAB direction. Vector unit vector AAB direction. Given A point is given, and there are two parts. Point B is 211. This is part A, and part B problem 356. These two different problems have been given. Right. Let me take up part A. Okay, straight conductor means we know that they are asking to find out the vector force, right? We know that the vector force that is acting on the straight conductor is IL cross B. Right, this we know. B vector is given, current I is given, right? So L vector, what is L vector? We have to decide, right? Okay, A to B, point A, let me, point A is 1 comma 1 comma 1. Then point B for part A, point B is 2 comma 1 comma 1. Okay, join this, right? A straight wire is carrying 12 amps of current in AAB direction, means current I is flowing in this direction, 12 amps, right? From A to AB. Then the length of the conductor should be AB only. So here the length of the conductor L we have to find out, right? So it should be vector, right? So it is nothing but here, nothing but the distance from A to B, RAB vector, right? So we'll find out this. So already we know I, we know B vector, we will find out L vector, right? So that is nothing but RAB will find out RA to B. So 2 minus 1, that is AX, then 1 minus 1, so this, sorry, point A, this is 1, right? 1 minus 1, so Y is 0, Z 1 minus 1, so only I am getting RAB is equal to AX. Is it fine? So this is nothing but my L vector. So magnitude of L is 1 meters. If it is in meters, so L is equal to 1 meters. The distance also is associated in x direction. This is in x direction, right? Okay. So first we'll find out L cross B. Then we'll find out I. Or else anyhow, just observe L. L is only there is, it is having only x component. Y and Z are absent. So directly we can do. No need of determinant here. So I is 12 amps. So open bracket L cross B. So L is AX. Then cross product with B. B is minus 2AX plus 3AY plus 4AZ. Millitesla. Milli means 10 power minus 3. Yes, AX cross AX is 0. So we will take the cross product. So for that, in order to calculate the cross product of unit vectors, I will take the help of this cyclic pattern. Right. Okay. Okay, just will multiply 12 to ja 24 minus 24. 12 into 2, just I'm right, 12 to ja 24 minus 24. So AX cross AX, it will be 0, right? AX cross AX is 0 because sin 0 is 0. So I will not write this first term, right? Then AX cross AY. AX cross AY, sorry, AX AY, this is AZ. AX cross AY is AZ, right? So I'll be getting AZ from second term. 12 3 ja 36. 36. AX cross AY is AZ. 36 AZ I am getting. Then next, AX cross AZ. AX cross AZ. I am coming in reverse way. So it is minus AY. So I will be getting minus AY. So just multiply this. So 12 4 ja 48. So minus is there. So I will take minus 48. AX cross AZ is AX minus AY. Right. So into 10 power minus 3. Right, this is the final vector newtons. Just observe here, minus 48 ay, so minus 48 ay the 36 az, right, into milli means 10 power minus 3 newtons. Part A is over. Next we'll take up part B. So here point B is 3, 5, 6. 3, 5, 6. So we'll once again the same thing. Point A is 1 comma 1 comma 1. Point B 3, 5, 6. So current I is flowing in the unit vector direction AAB. This is AAB, right? So current I is flowing in this direction. 15 amps they have given, right? Sorry, 12 amps, not 15, 12. Okay, then here once again the same formula, IL cross B, because this is a straight conductor. IL cross B. So we know B, we know I, L we have to find out. So L vector is nothing but the distance vector RAB. So we'll find out this. A to B means 3 minus 1, 2AX. Then 5 minus 1, 4AY. 6 minus 1, 5, 5AZ. Right? Okay. So first we'll find out the cross product. L is also having all the components, X component, Y component, Z component. B is also having all the components. It is better to make use of determinant. So first I will find out L cross B, then I will multiply with I. So we will go for determinant. We'll take the help of determinant. So anyhow it is in Cartesian system. So first row AX, AY, AZ. Write down the unit vectors in Cartesian system. Then write down the components of L vector 2, 4, 5. Then write down the components of B vector minus 2, 3, 4. Minus 2, 3, 4. But milli is there. Milli means 10 power minus. So I will take it outside. 10 power minus 3. Common, right? So find out this plus, minus, plus. So AX into, just I will directly calculate and write it. So leave this column, leave this row. 4, 4 just 16. 16 minus 15. 5, 3 just 15. 16 minus 15 is 1. So minus AY vector. Leave this column, leave this row. So 4 2 is 8. 8. Then next minus into minus it will be plus. So 5 2 is 10. 8 plus 10, 18. So 18 I am getting here. Plus AZ. So leave this column, leave this row. 2 3 is 6. Then minus into minus it will be plus. 4 2 is 8. 4 2 is 8. So I am getting 14 AZ. So 10 power minus 3 is there. So don't miss it. Write it. Right? Minus 3. So L cross B. Then multiply with I. So F is equal to I is how much? 12 amps. Right? So we will multiply 12 for this directly and write it. So we will multiply L cross B is here. Just multiply I. 12. 12 AX minus 12 into 18. 12 into 18. So I am getting 216 AY. The next 12 into 14. So 168 AZ into 10 power minus 3 newtons. So vectorial force they have asked. So just cross verify 12 AX minus 216 AY plus 168. It's milli means 10 power minus 3, right? So they are asking vector force. If it is asked to calculate the magnitude, so under root of 12 square plus 216 square plus 168 square, right? Okay. Next we'll start with the next topic in this chapter, that is force between differential current elements. Yes, there are two diagrams. This is diagram 1 and this is diagram 2. Just I will draw the bifurcation line, right? This is diagram 1, diagram 2. So this is one straight current carrying conductor. This is another straight. They are separated by some distance, right? Let us assume that the current I1 is flowing in the upward direction through this straight filament or straight conductor, and I2 is also flowing in the upward direction. Means through this, let me call this as differential current elements, right? This is one differential current element and this is another differential current element. The current I is flowing in the same direction, means they are flowing in the upward direction in both the differential current elements, right? So whenever the currents are flowing in the same direction, right, in the differential current elements, there exists the attractive force between them, right? They will attract each other. So there exists attractive force between them. Then observe the second diagram. So two differential current elements are there. in one of the current element, the current I is flowing in the upward direction. In this, it is flowing in the opposite direction as compared to the current element 1. So whenever the direction of currents are in opposite direction, there exists repulsive force, right, between the two differential current elements. Repulsive force, right? Repulsive force. So please keep this in the mind. You know, with respect to charges, we have seen like charges repel and unlike charges attract. So in the same way, whenever the direction of flow of current is same, then there exists attractive force between the differential current elements. Whenever the current direction is in opposite direction, then there exists repulsive force between the two differential current elements, right? Okay, having this in the mind, so we will find out what is the force exerted on each other, right? So this is also generating magnetic, this is also having magnetic flux lines around it, this is also having magnetic flux lines around it. Suppose, let me assume that this is the source of magnetic field, and I want to find out what is the force acting on this current element 1 due to this magnetic field. Then in another way, I want to find out what is the force exerted on current element 2 due to the magnetic field lines generated by the current element 1. The vice versa, right? We'll see that. What is the formula we are going to get? So here you can see here, simple circuit, there's a battery here and simple current carrying conductor or loop is there. Current I1 is flowing in this direction, right, from positive terminal of a battery. This is the conventional current. Similarly, another current element 2 they have taken, right? So here the current I is flowing in this direction. We will consider the differential current element, means only small piece. I will not take the entire loop. So we'll take this small differential current element 1. This is I1 into DL1. Differential length is DL1, right? So current I1 is flowing in this. So I1 into DL1. So differential current element 1. Similarly, we will consider the small differential current element 2 here, I2 DL2. Right? Observe here, the current is flowing in this direction, in this differential. Here also it is flowing in the same direction. If I consider these two differential current, they are flowing in the same direction, that is upward. So the attractive force exists between them, right? So here in this case, the attractive force exists between them. So let us call this as attractive force, right here. Okay, fine. Next, observe here, I want to find out what is the force exerted on current element 1 due to the magnetic field generated by current element 2, right? Let us assume that this is the source of magnetic field. Source of magnetic field, or else we'll call it a source point, which is generating magnetic field, because every current carrying conductor has magnetic field surrounding it, right? So let me assume this as a source. So I want to find out what is the force experienced by current element 1 due to the magnetic field generated by current element 2. This is one case. In another case, we can find out the force exerted on current element 2 due to the magnetic field generated by current element 1. That is vice versa, right? So first we'll concentrate only on this. So this is the source of magnetic field, and we want to find out what is the force experience or force exerted on current element 1 due to the magnetic field generated by current element 2. Right? The same thing has been written here. Yes. If it is a straight conductor, we have seen F is equal to IL cross B, right? IL cross B. If it is a straight conductor, these are straight conductors only. If I consider the smaller length, right? Smaller length. So IL cross B. But we have considered the differential current element. So DF is equal to IDL cross B. This is the main equation, right? So then the small differential force, vector force acting on the current element 1 due to the other current element is given by IDL cross B. Is it fine? IDL, small differential length, cross the magnetic field generated by another current element, right? IDL cross B. Okay, this is differential force. So due to this differential element, the differential force that is exerted on current element 1, so instead of this F, dF we will write. For F, dF, differential force. So d of dF1, I will come to the notation later. 1. So d of dF is equal to IDL cross dB. IDL cross dB. So why this prefix suffix I will tell you. So the vector force exerted on current element 1, so the differential force dF1, right, is equal to the current element I1 dL1 cross dB2 means this is the source of, this is magnetic flux density, right? So current element 2 is the source of magnetic field, so dB2. Don't write dB1 because source of magnetic field is current element, so dB2. I hope you got it. Then we know the relationship between B and H. B is equal to, let us assume that this is placed in free space. So B is equal to mu naught H, right? But I want dB2, right? So dB is equal to mu naught h, right? So here dB2 is equal to mu naught h2, sorry, mu naught dh2, mu naught dh2, right? So we can find out this differential magnetic field intensity by Biot-Savart law, right? By Biot-Savart law, right? We can find out this dB2. So what is this dB2? Just I will write it here. Just observe here. We are finding dB2. dB2 is equal to mu naught dH2. Mu naught as it is. What is dH2 by Biot-Savart law? So ideal cross AR by 4 pi R square. Ideal means the current element 2, I2 dL2 cross AR by 4 pi R square. From where to where? Source point to field point. So this is the source point and this is the field point where we want to find out the magnetic field, sorry, force, right? So this is source point. So always it should be from source point to field point. This is 2 and this is 1, 2 to 1. So AR 2 to 1. So R 2 1 square. I hope you are getting this, right? Okay, this is first case. I hope you came to know how to write. Then substitute this value of dB2 here. This is dB2, right? So substitute this value of dB2 and write down the differential force on acting on current element 1. So we'll substitute. So I'll be getting mu naught. So just mu naught is taken outside. I1 dL1 cross dB2. I1 dL1 they have written first, then cross of this entire thing, right? Mu naught is just taken out. Then next, in second case we have discussed, we want to find out what is the vector force exerted on current element 2 due to the magnetic field generated by current element 1. So we have written the formula here. So this is ddf2, right? So this is the formula. So use the same thing, I2 dl2 cross db1 it will become, because source of magnetic field will be current element 1, db1. So after finding db1 and substituting, I will be getting mu naught into I2 dl2 cross I1 dl1 cross ar12 by 4 pi r12 square, because r1 to 2, why it is 1 to 2? Source will become, this is the source of magnet, source point to field point. So 1 to 2. I hope you are getting. So remember one formula, you will get the other one. So it should be knowing. Then we have considered only differential small elements, but due to the entire loop, so integrate, this is ddf means integrate twice, so that we will get the total force acting on current element 1 due to current element 2, right? So this is f1 and this is f2, and f2 is equal to minus of f1, right? It is, the force is attractive force. This, let me call this as f1 and this as f2. So f2 is equal to minus of f1, right? It is simple. They are equal but opposite in direction, right? So f2 is equal to minus. But no need to remember these equations. We have to remember these two equations. I will tell you how to write. If you remember this much, that is sufficient. ddf1 is equal to I1 dl1 cross the source of magnetic field dB2. For dB2 we know how to find out. So mu naught h, I know how to write by using Biot-Savart law, right? So in the numerical, I will tell you how to write the formula before proceeding with the numerical. If any doubts, please unmute yourself so that I can clarify your doubts if any. Okay, next, before seeing the numerical, this is one more concept we'll see. Yes, two infinite current elements are there. This is infinite in length. Yes, it goes towards infinity. This is right. Two infinite current carrying conductors. In this first conductor it is flowing in this direction. In this it is flowing in opposite direction. Whenever they're flowing in opposite direction, right, there exists repulsive force, right? F, repulsive force between the two infinite straight current carrying conductors. They are separated by distance d. Then we'll take up the direct formula. We'll not see the derivation, right? So by making use of this only we will get, but we'll not see how we are getting. So F is equal to the total force, the repulsive force is given by mu naught into I square by 2 pi d Newton per meter, right? So D is the separation between the two straight conductors, right? Just try to remember this. We will not solve any numerical. It may help you in any of the exams, right? F is equal to mu naught I square by 2 pi d. Okay, we'll take up this example or numerical. Okay, consider the two differential current elements. I1 dl1 is equal to minus 3y amp meter located at this point, and I2 dl2 is equal to minus 4 az amp meter at this point. Find the differential force on dl2. Yes, we'll try to analyze, right? So see here, sometimes instead of I1 dl1 they can give like this also. In some textbook I1 delta L1 also they will give. They are both one and the same. I1 delta L1 instead of I2 dl2 they will give I2 delta L2. one and the same, right? Don't get confused, right? Okay, two current elements are given, right? This is one current element and this is another current element. So it is first current element I1 dl1, I1 dl1. So second current element is I2 dl2, right? Okay, it is located at point P1 of 5 comma 2 comma 1. Another current element at 1 comma 8 comma P2, that is 1 comma 8 comma 5. What they are asking, find the differential force on dl2. dl2 means we want to find out what is the force exerted on this current element 2. This is current, let me call it, let me write it, current element 1, current differential current element or current element 1, then current element 2. Then they are asking find the differential force on dl2 means find the vector force on means ddf2, the differential force that is exerted on current element 2 due to current element 1. So ddf2, you should be very careful whether you are finding ddf1 or ddf2, differential current, the force, right? So the differential force that is acting on current element 2 due to this current element means this is the source point, because it is the source of magnetic field is current element 1. So in this magnetic field, due to this magnetic field, whenever this current element is placed in the magnetic field of current element 1, what is the force experienced by this current element 2, we want to find out. Okay, we know that F is equal to IL cross B, right? Right, so ddf2 is equal to, so I2 dl2, just I2 dl2, right? dl2 cross. So here B vector means here dB, which is the source of magnetic field. It is current element 1. So dB1 vector. I hope you are getting. If you write, then it is as good as you have written the formula itself, right? So I2 dl2 into source of magnetic field is dB1, right? This is the source. Okay, next we will, what is this? We know B equal to mu naught H, right? We will write down the final formula. Just I will tell you how to write it. So B equal to mu naught H, right? So mu naught I will take it here. Mu naught into this one I will write. Observe here I2 dl2. How to write the formula I am telling. And then cross product. Then we know this is dB1 is just I will write it here for your reference. dB1 is equal to mu naught dH1. So mu naught I have written here. So what is dH1? By Biot-Savart law, right? So I1 dl1, the current element I1 dl1 cross of AR, so close the bracket, divided by 4 pi r square, 4 pi r square. But we have to tell the distance from where to where the unit vector is there, from which distance we are, from source point to field point. So this is the source point and this is the field point where we want to find out the force experience. So 1 to 2. So AR 1 to 2. Observe here how to write the formula I am telling. I hope you got the how to write the formula. If you write this much, it will, you will get this formula. The ddf2 we have written here, this one, right? I hope you are getting. So once if you write the formula correct, then everything is just cross product. First we'll take this cross product, then we'll take this cross product. So first we'll find out this I1 dl1 cross AR1 to 2. So I1 dl1 we have. So but I want AR1 2. So let us find out AR12. So AR12 is nothing but the vector R12 divided by the magnitude of vector R12. So first we will find out vector R12. So R1 to 2. I have the points here. 1 to 2 means 1 minus 5 minus 4ax. Then 8 minus 2, 6ay. Then 5 minus 1, 4az. Then find out the magnitude R12. So under root of, so I will calculate this, under root of 4 square is 16, then 6 square is 36, plus 4 square is 16 once again. So 8.246. Okay, we have AR12. So let us calculate AR12. AR12. The vector R12 is here, magnitude. So divide this vector R12 by this magnitude and write on the final vector. So I will divide and write 4 divided by 8.246. So I am getting it as minus sign is there. So take this minus 0.485. I will take up to 3 digits, 0.485 AX. then 6 by 8.246, so 0.72 plus 0.727 AY. The next 4 by 8 point is nothing but 0.485 once again AZ. Okay, now I have this AR12 vector I1 DL1. Next I'll take the cross product I1 DL1 cross AR12. So I1 DL1, observe here, it has only Y component, it doesn't have X and Z components. So directly we can cross multiply, no need of determinant, right? So I1 DL1 is minus 3AY. Minus 3AY. Then cross product with AR12. Here we have found out AR12 here. So let me write it in the bracket, minus 0.485 AX plus 0.727 AY plus 0.485 AZ. So we'll take the cross product. So I'll take the help of this cross product of unit vectors AX, AY, AZ, this cyclic diagram. Observe AY cross AX. So AY cross AX means minus AZ I will get. So minus into minus plus, plus into minus minus, because AY cross AY cross AX is minus AZ. That minus also will come into picture. So once again minus 3 into 0.485. 3 into 0.485. So I am getting it as 1.455. So AY cross AX is minus AZ. So minus already taken, AZ I have to write. Is it fine? Minus is taken. Next AY cross AY, second term. It will be 0. AY cross AY is 0. Then come to the third term. AY cross AZ. AY cross AZ is AX. But minus sign is there. Minus 3 into. So minus 3 into 0.485. So already it is, we have done 1.45 only. 1.455. 3 into 0.4, right? Minus into plus, it's minus. But AY cross AZ. AY cross AZ is AX. So this is AX. I hope you are getting. Okay, this cross product we have found out. Next, this is we have, right? Then next, take the cross product with I2 DL2. So we will find out this numerator, entire numerator, I2 DL2 cross I1 DL1 cross AR12, right? So we will find out this I2 DL2. What is I2 DL2? Minus 4AZ. Then take the cross product with, already we have found out this cross product. Here it is, minus 1 point, let me write AX first, minus 1.455 AX then next I will write AZ minus 1.45 AZ, minus 1.455 AZ. Okay, AZ cross AX. I want AZ cross AX. AZ cross AX is AY. So AZ cross AX is AY I am getting. Then 4 into minus it will be plus 4 into 1.445. 4 into 1.455. So I am getting 5.82 AY. Then AZ cross AZ, it is 0. Second term will vanish. So I am getting only this much, this numerator part. This is over. So mu naught we know, it is 4 pi into 10 power minus 7. And we will substitute in the formula. We will take this formula DDF2, the differential force on current element 2, DDF2 is equal to mu naught. Mu naught is nothing but 4 pi into 10 power minus 7. It is not cross product, right? So this entire thing into. So if I put cross, you will feel that it is cross product. So just I will take the bracket. Right, mu naught. So this entire numerator, it is here 5.85 AY we got. This entire numerator divided by 4 pi r square, right? 4 pi. What is that? R12 square. What is R12? R12 is 8.246. 8.246 whole square. So we'll calculate 4 pi will get cancelled. So we'll divide and we'll calculate how much we'll get. So 5.85 divided by 8.246 whole square. 246 whole square. So I am getting it as 0.0860. into 10 power minus 7 newtons, right? So usually we will express in either minus 6 something like that. So if it is minus 6, one digit we have to go, right? So let me, or else we can leave it here also, but let me check it. So 8.56 nano they have given in terms of 10 power minus 9. 10 power minus 9 means 2 digits front, so it is 8.6012, right, into 10 power minus 9 newtons. 8.6 nanonewtons, 8.6 nano, but ay is there, don't leave this ay, I have left it. So write down ay because it is vectorial force, right? So 8.6 nano ay newtons. So let me rewrite this once again. Ay vector newtons. Is it fine? Okay. Next. Already we have found out DDF2. Let us take one more problem in which we will come across DDF1 formula, right? Okay, we will take up this numerical. So two differential current elements I1 delta L1 is given at this point and I2 delta is given at this point. Then are located in free space. Find the vector force exerted on current element 2 by current element 1. I2 delta L2 means current element 2 by current element 1. Next, find out the vector force exerted on current element 1 by current element 2. So we'll take up this part B. Part A is similar to, because part A formula is here already. The same formula will come here. How to write the formula I told. So I'll be taking up part B, right? Part A I'm leaving it to you people. Yes. Find the vector force exerted on this current element 1 by current element 2, right? So we want to find out DDF1, the differential force exerted on current element 1. So how to write it? So we know the formula F is equal to IL cross B. You keep it this by side so that it will help you to write. So ideal so it is I1 dl1, right, cross it is dB, which is the source of magnetic field. So source of magnetic field is current element 2, so dB2 will come, right? dB2. I hope this is fine. I1 dl1 cross the source of magnetic field is dB2 because this is the source of magnetic field. We want to find out what is the force exerted on this current element 1 due to the source of magnetic field by current element 2. So dB2, right? I hope if you write this much, formula itself is over. Okay, we know that dB2 is equal to, just I will write by side, dB2 is equal to mu naught into dH2. Okay, just with this we can write by Biot-Savart law, right? So mu naught I will take it outside, mu naught. The next I1 dl1 as it is I will write I1 dl1, then cross product of dB2 is nothing but mu naught already taken dH2. We know by Biot-Savart law. So I2 dl2, current element 2, I2 dl IDL cross AR by 4 pi r square, 4 pi r square. Okay, this distance is important. Where from source point to field point, which is source point and which is field point. So source point is 2 to 1, right? 2 to 1. So 2 to 1. If I write this much, yes, 50% of the problem is solved. Right formula should be, we have to write the right formula, right? Okay. Next, I2 dl2 will take up. So first we'll find out the cross product of I2 dl2 cross AR21. First we'll find out AR21. So AR21 is nothing but R21 divided by magnitude R21. Is it fine? Okay. Then next we'll find out R21. So here let me write down those points. P1 of 1, 0, 0, P2 of 2, 2, 2. So 2 to 1. 2 to 1 means we will subtract like this, right? 2 to 1 means 1 minus 2. So minus AX. Then 0 minus 2 minus 2AY. 0 minus 2 minus 2AZ. So find out the magnitude R21. So under root of 1 square is 1 plus 2 square is 4 plus 2 square is 4 once again. So I am getting 3. So we'll find out AR21. So this is the vector divided by magnitude 3. So we will divide and write. So or else let's simply I will write. So minus ax by 3, simpler like this, minus 2 by 3 into ay, minus 2 by 3 into az. Okay. Observe here. I want AR21 is fine. I2 DL2. Observe I2 DL2. Yes, it has all the components: x component, y component, z component. It is better to go for determinant. So I will make use of determinant. So I will calculate this I2 DL2. I'll go to next slide. I2 DL2 cross I2 DL2 cross AR21. So this is anyhow in Cartesian system. So AX, AY, AZ. Then write down the components of I2 DL2. I 3 into 10 power minus 6. I will take it outside. It is anyhow common. Then components of x, y, z are minus 0.5, 0.4, minus 0.5, 0.4. The next 0.3. This 3 into 10 power minus 6 is taken outside. Then next, write down the components of this vector AR21. AR21 is here, minus 1 by 3. The next minus 2 by 3. Here it is minus 2 by 3. Is it fine? Okay. Next we will calculate this plus, minus, plus. So plus AX. Leave this column, leave this row. Calculate this. So minus 2 by 3 is how much? Minus 2 divided by 3. So it is minus 0.66 into 0.4. This is over. Then minus of, right? So minus into minus it will be plus. So plus 0.3 into minus 2 by 3. Minus 2 divided, sorry, 1 minute, I will do once again. Or else it is better to write the fractions only. Just let me write the fraction 1 by 3. So 0.33. So instead of this minus point, let me restrict 0.33. This would be better, I think, right? Or else I will restrict to 2 digits, right? Then 2 by 3 is how much? So 0.66 minus 0.66. So minus 0.66. This would help me. So leave this column, leave this row. 0.4 into, just let me put the brackets, 0.4 into minus 0.66. Then minus of, open bracket, minus 0.66 into 0.3. So I can calculate at a time, right? So this will help me, minus 0.066. Then minus AY, leave this column, leave this row. So open bracket, minus 0.5 into minus 0.66, minus 0.66. Then minus of these two, right? So 0.3 into minus 0.33. So minus, sorry, 0.429 I am getting, plus AZ. So leave this column, leave this row. Then open bracket, minus 0.5 into minus 0.66, minus of, so 0.4 into minus 0.33. So I am getting it as 0.462. But this 3 into 10 power minus 6 we should not leave. So write it 3 into 10 power minus 6. So this is over. Just this only this much is over. Then I1 DL1 cross this, right? So we'll find out that. So I1 DL1 cross this entire thing. Already we have found out this. So I2 DL2 cross AR21. So observe I1 DL1. I1 DL1 is having only y component. So directly I can do. So we'll write it here. I1 DL1 is 3 into 10 power minus 6. 3 into 10 power minus 6 AY. Cross product of. So this I'll put it in the bracket and write, right? Okay. Minus 0.066 AX minus 0.429 AY plus 0.462 AZ. Yes, this one 3 into 10 power minus 6. I can merge with the 3 3 9, right? So I will rewrite here 3 3 9, this one, right? 3 3 9. 3 into 3, right? 9. The next 10 power minus 6, 10 power minus 6. So it is 10 power minus 12, right? Directly I am writing 9 into 10 power minus 12 AY. Okay, just 10 power minus 12, I'll take it outside. So AY cross AX I want, cross product. So I'll take the help of this cyclic pattern AX, AY, AZ. So what is AY cross AX? So AY cross AX is minus AZ. So this minus this, it will become plus. So 9 into point, this I will multiply. 9 into 0.066. So I am getting 0.594. 0.594. Plus into minus, I am getting minus, but let me check AY cross AX. AY cross AX is minus AZ. So minus into minus, it will become plus AZ. I hope you are getting what I am doing. The next second AY cross AY is 0. Leave it. The next AY cross AZ will go. Before that, I will multiply 9 into 0.462. So 9 into 0.462. So I am getting 4. I don't know, sign will check it later. 4.158. Right now I have written, okay, let me take plus only. So 9 into 0.462 is 4.158. 10 power minus 12, I will take it later. AY cross AZ. So AY cross AZ is AX, it is plus only, right? Into 10 power minus 12. I hope this is correct. So entire numerator is over, this one in the formula. Next, we will see the final formula. DDF1 is equal to mu naught. Mu naught is nothing but 4 pi into 10 power minus 7 into means I will put the bracket, or else it will take it as a cross product. This entire thing we have found out. So it is nothing but 0.594 AZ plus 4.158 AX into 10 power minus 12 divided by 4 pi r square, right? 4 pi into r square. What is r square? R21. It is 3 square, 9, right? So it is 9. Okay, fine. 4 pi will get cancelled. And this 9 I have taken care, right? Yes, I have taken care. Already I have multiplied, or else it would have cancelled, right? Okay, anyhow I have multiplied, no problem. 4 pi will get cancelled, and we will calculate the other things. So 10 power minus 7, 10 power minus 12, I will write it later. So 0.594 divided by 9, I will write 0.594 divided by 9. So I am getting 0.066 AZ. Then 4.158 divided by 9. So I am getting it as 0.462. 0.462 AZ, sorry, AX. Into 10 to the power of, so minus 7 minus 12, so minus 7 minus 12, so I am getting minus 19 newtons. This is the answer, right? DDF1. So let me check the answer. They have given in terms of minus 20, second one, right? We were solving second one. So let me write it in terms of minus 20 means what will happen? What will happen? 10 power minus 20 means, so one digit front. Yes, one digit front. So first they have written AX, then AZ. So let me write AX first. No problem, you can write in any way. So 4.62 AX. So this one takes shift digit, one digit, 0.66 AZ into 10 power minus 20 newtons. Is it fine? Right, 10 power minus 1 has been added here. So just multiply 10 for it. So 4.62 or 4.33 they are getting, but we are getting 4.62. Then 0.66, 0.667 they are getting. Is it fine? So part A, please you do it as a homework. So homework part A, and this answer is given here, right? Please check it. Then I hope we will wind up the class today, and you take this problem. I'll stop recording. You take this problem also as a homework.